Mr. Stewart, what a nice looking bean plant you have there.
Why, thank you, Mr. Pepper. I was just about to take some measurements of it.
What were you going to look at?
Well, first I was going to measure its growth.
Growth being height?
Yeah.
Alright, well, go ahead, get it to a measure it.
Alright.
What are you using there?
I've got my trusty plastic metric ruler here. Let's see. I'm going to try to measure from the bottom of the soil.
You want me to help you out here?
Thanks.
There's a
Oh! The ruler's not long enough. What should we do?
Well, if only there was another tool that was longer, like, say, this meter stick that comes in two sides.
Aha!
Which side do you want to use? The inches side or the centimeter side?
What kind of measurement system do we use in science?
I think we're going to use the centimeter side.
Metric. Alright.
There you go.
Thanks, Mr. Pepper.
How many centimeters tall is your plant? Let me help you out here.
There we go. Close up.
Yeah.
Wow, she's really been growing.
Looks like 49.5. Think that's a good enough measurement?
49.5. Is that as precise as we can get?
I don't know. Let's take a look.
As you can see here, the tip of the plant is between 49.5 centimeters and 49.6 centimeters. We should report 49.5 and then report one more digit, estimating the distance that it is between. I'm going to report 49.56 centimeters.
So, what you're saying is we have to make up a digit to indicate that it's just a little bit more than 49.5 and not quite 49.6?
That's exactly right.
That's awesome. So, what's next for our plant?
Well, we measured its length, now let's measure its mass.
Sounds good to me. What are we going to use?
For measuring mass in biology, we're going to use a electronic balance.
That's awesome. So all I got to do is just turn this guy on by pressing this button. Wait for it to load, because it takes a second. And then I'm just going to put this guy on right here. Oh, it's still timing. And then just put this guy right on. Does that work like that? That should give the mass of the plant.
Well, remember that we also have the soil on top of the balance and the pot.
So how do I accommodate for that?
Well, maybe we could measure the mass of a pot filled with soil, then measure the pot with the plant in it.
And just subtract the difference?
Subtract the difference.
That sounds great.
How can we correct that?
Well, I actually think that before we put this seed in the plant, we measured the mass of the cup in the dirt, and it came to about 15.01 grams for the cup and about 35.7 grams for the dirt.
Alright. So, seems if we take this mass and subtract the mass of the soil and the pot, that leaves us with only the mass of the plant.
Sounds like a plan to me. But, didn't you say before we had to add a digit? How am I supposed to do that with an electric balance?
Ah, you're right. Well, the thing about these balances is they are accurate to the first place past the decimal point. The second is an uncertain digit, so we don't have to add one ourselves.
And that's why it's flickering back and forth, so it doesn't really matter. We can just pick a number and write it down.
That's right. You choose one of the numbers that it's on.
Sounds good to me.
So if I take the mass of all three, subtract the mass of the soil, then I should get that, then subtract the mass of the pot, then I get the remainder, which is just the mass of the plant.
So, Mr. Stewart, what's next?
Well, we need to water my plant.
Alright, so I have a little water here. How do I measure how much water I'm going to put in?
Well, can't you just measure it using a beaker?
Unfortunately, beakers are really for storing and mixing chemicals. they're not really as much for measuring. If I want to measure accurately, I have to use this really fun device called a graduated cylinder.
Oh, that's right. Graduated cylinder.
So I'm going to say we'll put in between like 20 and 30 milliliters of water. Does that sound good?
That sounds about right.
So I'm going to pour it in. I'm not going to measure exactly, but I do want to find out how much water I give the plant. So let me pour a little water in. So it gets between 20 and 30, and we'll stop. So how much water does that look like?
Maybe 27?
27 looks good. Let me take a look. If I look from here, though, it looks like it's like 28. And if I look from here, it looks like it's 26. How do I know where I'm supposed to look? How do I know really how much water
that's
that
right.
is?
When you're measuring, you want to make sure you're at eye level with the graduated cylinder and that it's on a stable surface. Looks like we've got a flat, stable surface. And when I look at it at eye level, I can read, it looks like it's between 26 and 27. But there's actually this other part that's kind of above that. Which one do I read?
What you want to do is it's got this weird little bubble in it called a meniscus. And I can show you what that looks like when we go over to the board. When we read a graduated cylinder, water has a special property called adhesion. And when it adheres to the side of the graduated cylinder, it makes a little bubble called the meniscus. When we read water, any other liquid in a graduated cylinder that has this meniscus, we actually want to read from the bottom of the meniscus, which is why we put it at eye level. In this case, the water is between 26 and 27 milliliters in our graduated cylinder. So we know it's more than 26, but less than 27. So to indicate this, we're going to make another estimated guess as to what this is. We're going to say it's probably about 26.7 milliliters. Once again, we're sure that it's more than 26 and less than 27, but this digit is one that we're estimating. Now, there's something we didn't talk about before, and that's how to show that we're actually estimating a digit and we're not 100% sure that this is a 7. And it's something called uncertainty. What uncertainty is equal to half of the smallest increment. So in this graduated cylinder, what are the increments if it goes 25, 26, 27?
Well, let's see. Between 25 and 26 is one increment, so that's 1 milliliter.
Okay. So the increment is 1 milliliter. So what's half of the increment?
Well, 1 milliliter, I guess that's half a milliliter, or 0.5 milliliters.
So therefore, when we report our measurement, we say that our uncertainty is half of this increment, or half a milliliter. To write that, we would actually write this measurement as 26.7 plus or minus 0.5 milliliters. You know how you know you're right on these? If you get this measurement right, if this digit and this digit are in the same decimal place. So Mr. Stewart, are we ready to give this plant 26.7 plus or minus 0.5 milliliters of water?
We sure are.
Go ahead.